So on this one, I have two triangles that I'm going to have to look at. So for this first one, I'm going to draw in an angle. Again, tangent is positive for principal angles in first quadrant, because remember, for tangent, I get to use quadrants 4 and 1. Since it's positive, we'll be in quadrant 1. And we'll call this angle that we're seeking alpha. But we know that alpha's tangent value is 4/5. So that means the opposite is 4 and the adjacent is 5. And we could then find the hypotenuse with some Pythagorean theorem magic and just double check my math, make sure that it is in fact square root of 41. And then this one we'll call beta, and since it's positive, again, sine uses quadrants 4 and 1, so since it's positive, we'd be in quadrant 1. And so the sine value is opposite over hypotenuse, so the opposite side has to be square root of 3, and the hypotenuse has to be 2. And so if I do some Pythagorean magic, I'll get a 1 down here. And then I have to remember that my cosine of two angles, when they're being added, I use cosine cha-cha. So cosine, cosine, sine, sine, cosine, cosine, sine, sine, cosine, cosine, sine, sine. And cosine is kind of rebellious in the rules. He's not much of a rule follower. So if it was plus over here, then it'll be minus on the expansion, and vice versa. Ooh, I don't know where that accent came from. The expansion. So cosine, cosine, sine, sine. And notice that the angles stay in the same order. Alpha first, then beta. Alpha, beta, alpha, beta. So now when I plug in, I'm looking for cosine of alpha for this first term. So I would have to use the alpha triangle and generate the cosine value from it, which would be 5 over square root of 41. And for the second part, I'm doing cosine of beta, so I got to use the beta triangle, and the cosine is 1/2. And then I'll go back to my alpha triangle and get the sine value, which is 4 over square root of 41. And I'll go back to the beta triangle to get the sine of beta, which is square root of 3 over 2. And so when I multiply, I'll get 5 over 2 square root of 41 minus 4 square root of 3 over 2 square root of 41. And of course I can just put those together since they have the same denominator. So it'll be 5 minus 4 square root of 3 all over 2 square root of 41. And those are all things that you've learned in pre-calculus. Moving on to calculus. Okay, so I'm ready to start doing derivative with my inverse trig functions. So in order to do arc secant, remember my formula is u prime over absolute value of u, and then the square root of u squared minus 1. So for this one, I'm going to have y prime equals, so now I have to remember what the u is that I'm taking the arc secant of, and it's this stuff. So if I want the derivative of it on top, it's going to be 2e to the 2x. And on bottom, I'll have the original problem in the absolute value. And then when I square it, so e to the 2x squared is e to the 4x minus 1. And doesn't look like I can simplify that. Actually, just kidding. I can, actually. Did you notice? And there's my final answer.